Hey everyone, today we're going to be talking about coolant temperature sensors. As I said in the previous video, this is basically for an E30 M20, but it does cross over to other models. So check your, the sensor values might not be the same necessarily. The testing is probably going to be the same. A lot of times the values might even be the same because these sensors were used for different engines. So just double check. If you're not sure of the values, look it up, but we're just going to talk about M20. I believe this is probably the same as M30, maybe even M42, but double check it. So on M20, on a 2.5, I don't know about the other 2.3s or something like that, but on 2.5 you've got two temperature sensors on the engine. You have your temperature sensor for the gauge, which is a single pin sensor, and you have your temperature sensor for the DME or ECU, whatever you want to call it. It's a 2-pin sensor. Now, a lot of guys, again, have problems. As I said in the previous video, please check for vacuum leaks first. If you're not sure what I'm talking about, watch the previous video. So guys will have issues and they'll immediately start changing things, and the sensors are one of them. But let's talk about the actual values you should be getting from these sensors and how you should actually be testing it instead of just changing it. So let's start with the sensor that really doesn't matter very much in terms of operation. This is the single pin sensor for the coolant temperature gauge. Now, E30 gauges will sit usually center or a little bit higher than center. Don't be alarmed. Some guys think like, oh, it's a little bit over center, it's overheating. It's not overheating. Check it with a thermometer, infrared thermometer, because most of the time a hair over center is actually where it's supposed to be. Second thing is those gauges are really not very reliable. So a good idea would be to, if you actually, I would say, have your cluster rebuilt. It's a great idea. Bavarian Restoration, Greg and the guys over there, really awesome. So if you want to make sure your gauge is accurate all the time, get it rebuilt. There's a lot of different things that can go wrong, solder joints and stuff like that. So if you're having any weird issues that you can't fix, a lot of times you could, there's a nut on the back of the cluster which gets loose or corroded. That's a grounding nut. The gauge might kind of flop around a bit. Same for your gas gauge. Sometimes no matter what you do, it's never going to be fixed, and your best bet is to have it rebuilt. Anyways, so the sensor for the gauge. It's a single pin sensor, and the way this works is it's resistance between the pin and ground. So first thing to check, let's say your gauge is not working at all. Simple way to just check what's going on: to unplug your connector here, put a paper clip, wire, whatever, into that pin that's right there, and just touch that to ground, and either have someone check or have it held on a ground. Your gauge should be full hot. If your gauge is full hot, then you know that the wiring between the connector and the gauge are good, and the gauge should be good. Another thing to just double check, if you don't have any movement, or it's basically just reading off. If it's reading, let's say, full hot all the time, when you disconnect it, it should drop to full cold, like before full cold. If that doesn't happen, you have a short somewhere, again in the cluster or the wiring. If you're not getting very consistent readings, and you've checked both hot and cold operation, I would say remove this sensor, clean it off. The sensor needs to have a good ground. Make sure, like, if your thermostat housing has been painted, or a lot of guys mistakenly put Teflon on these threads here, but this actually seals on a washer at the very bottom here. It's a crush washer that actually seals it. So don't use any kind of sealant or anything on this sensor. Make sure that it's clean. Make sure where it goes into the thermostat housing is clean. If all that checks out and you're still not getting your proper readings, then go ahead and replace this. Like I said, this is not really a big deal. It doesn't control operation of the engine whatsoever. Now we'll move on to the 2-pin sensor. Now the way this sensor works is you have a reference sensor, a reference voltage rather, from the DME, 5 volts. This reference voltage is on one of the pins on the sensor. So as temperature increases, the resistance through this sensor decreases. So you'll have 5 volt reference, and then you'll have a voltage out, and that voltage out tells the DME what the engine temperature is. So I don't know what the voltage is exactly, but if you have, let's say, 5 volts in, and you might have 3 volts out, you might have 2.5, depending on the temperature, it's going to vary slightly. But so now to test this guy, first you're going to want to disconnect it, put the key on, make sure you have that 5-volt reference on one of the pins. Let's move on to testing the sensor now. Now, Bentley manual, great to have. If you don't have it, I'm going to tell you right now. So at 14 degrees Fahrenheit, plus or minus 2 degrees, you should have 7,000 to 11,600 ohms at this sensor. On the low end, it's not so much of a big deal. There's quite a bit of variance, but that's really cold. So generally speaking, if things are that cold, you're going to be dumping a lot of fuel when it starts up. Now at 68 degrees, you should have anywhere between 2,100 and 2,900 ohms across these two pins. Again, that's with the connector disconnected. And at 176 degrees, plus or minus 2 degrees, you should have 270 to 400 ohms across there. So we're going to check right now. In here, it is about 86 degrees. So we take our multimeter here and check it, put it on the ohm settings, and let's check across the sensor. I don't know if I could hold it up here at the same time to show you guys, but let's see here. So we've got about 1.4K ohms. Now at 68 degrees, it should be 2,100 to 2,900. And at 176 degrees, it should be even lower at 270. So the fact that we're at about 1.4, that's pretty close to what it should be. It's under the 2,100 at 68 degrees, so we're trending in the right direction there. I would say that's good. If your engine's up to temperature, that's a good way to check it as well, to kind of take out any variance with outside temperature. If your engine's at 180 degrees, you should have somewhere about 270 to 400 ohms, give or take. And that's really it. Now, I don't have the sensors here, but you also have, on a 2.7, you have 2 other sensors. And I'm going to kind of just reference the Bentley here because I don't have them to check. But on the 2.7, you've got the thermo time switch, which is for your cold start injector. Now, like I said, I'm just going to read kind of out of the book here to check things, or I could even maybe I'll just take a picture of it, so you guys could just read it as you please. That's what I'm going to do. I'm just going to take a picture of the Bentley, so you guys could just reference how to test that sensor and how to test the cold start injector. You have the thermal time switch, which controls the cold start injector. Then also on the E, you have the coolant temperature switch, which controls idle. The E has that separate little idle computer. It controls idle, and it also controls timing. So those 2 sensors are important on the E model. The coolant temperature switch is super important. The thermal time switch is important, but if it's not working, at the most, you might just have like a hard start. So not a huge deal if that's not working, and I know they are actually very expensive. So again, it's just something you don't want to just change for no reason. I think that basically sums this up. So coolant temperature sensors, and maybe next week we'll talk about, I don't know, injectors, or maybe thermostats, something else on